All right, now that we're getting used to doing some of these Pythagorean theorem problems, we're going to do a few word problems to kind of get used to when you might use this in real life. So here's a couple of pictures that show potential uses, but let's get into a specific problem. First of all, here's the steps for using the Pythagorean theorem to solve a word problem. First, if you don't already have a picture, draw a right triangle picture to fit the situation. Label each side using the information provided and identify the side you are asked to solve for. Then set up an equation to solve the problem and then accurately use that Pythagorean theorem equation to find the answer you're looking for. All right, for example, we've got a picture already drawn. Here's a triangle. This is the height right here. It says the bottom of a ladder must be placed 4 feet from the wall. So I'm going to write down here 4 feet from the wall out to the bottom of the ladder. The ladder itself is 14 feet long, which means that I'm going to be trying to find this measurement right here. And when I see that, I think of height, but also A for altitude. So then if I write down my equation, I write down A squared plus B squared, or the bottom squared, is equal to 14 squared. Okay, so let's keep it going. A squared plus 16. We got to make this neat. Let's get a better font there. A squared plus 16 equals, and then 14 squared, when we do that on our calculator, what do we get? So you just get 14 and hit x squared, or you can do 14 times 14, and you get 196. 196. Then we subtract 16 from both sides, and we'll end up with A squared equals, and then 196 minus 16 would be 180. And then all we have to do is do the square root of both sides. And so the square root of 180 on my calculator comes out to be about 13.4. Now, we didn't say anything about rounding, so we need to watch for that terminology. But 13.4 feet up that wall is about where it would reach with the information we have given here. Okay, how about this one? A 12-foot ladder leans against the side of a house. The bottom of the ladder is 7 feet from the side of the house. So the ladder itself is 12 feet long, and the base of the ladder is 7 feet out from the wall. So it looks like we're going to be looking for A again. So we have A squared plus 7 squared equals 12 squared. And when I do this, then I'm going to end up with A squared equals 144 minus 49. All right, so A squared, give ourselves a little more room. A squared equals 144 minus 49. That's going to put us at 95. And then when you do the square root of both sides, that'll give us A equals the square root of 95. 95 is 9.7. rounded to the nearest tenth, as it mentions in the homework. Okay, good job. Keep it going. Okay, a basketball court is in the shape of a rectangle, 60 meters wide and 75 meters long. So 60 wide, 75 meters in length. The coach asks the players to sprint from one corner to the diagonal across the court. So basically the court is asking everybody to run from one diagonal to another. So that would be the hypotenuse, right? So the question is, how long is that? I guess we could call that a squared plus b squared equals h squared. All right, so now what's 60 squared plus 75 squared? So on my calculator, I do a little calculating, and 60 squared ends up being 3600, and 75 squared, 75 squared, 75 squared is 5625. So if we put those two together, we get 9225. We end up with 9225. And now we're going to do the square root of both sides. So we're taking the square root of 9225, and we are going to get 96.0 if you round it to the nearest tenth. 96.0 feet, right? No, meters, sorry. Meters. So that's pretty long. If you're going to run across diagonally, that's a pretty good distance, isn't it? Okay. All right, John leaves school to go home. So let's get this up and ready to go. So here's the school. He leaves the school and he walks 6 blocks north. So we're going to go this way, 6 blocks north. Then he turns 8 blocks west. So he goes 8 blocks to the west. The question is, how far from home is he at that point? So he's going to be looking for the hypotenuse. So let's just set this up. 6 squared plus 8 squared equals the hypotenuse squared. The 6 times 6 is 36. 8 times 8 is 64. Okay, so 64 plus 36 equals 100, and that equals c squared. So when we take the square root of both sides, guess what we get? You guessed it, c equals 10. So c equals 10, and on to our next problem. In an advertisement, a computer monitor is listed as being 18 inches. This distance is the diagonal distance across the screen. So we're told that this distance right here is 18 inches. We're also told that the screen height is 10 inches. So the question is, how long is the base down here? And so how do we find that? Well, we know the hypotenuse and one of the legs. So we're looking for b down here, the base. So we'll go a squared 10 squared plus b squared. So 10 squared plus b squared equals 18 squared. Or b squared equals 18 squared minus 10 squared. And that's a pretty easy problem to do on a calculator. So 18 squared minus 10 squared equals 224. So b squared equals 224. And then you do the square root of that, and you get 14.96. All right, so b equals 14.9. All right, so if b equals 14, that's our answer, right? Okay, let's see how many more problems. We got one more. We can do it. The length of a shadow of a building is 28 meters. So first of all, let's draw the building. And then the length of its shadow, I'm going to do a dashed line to indicate where the shadow gets out to. So the length of that shadow is 28 meters. And it says that the distance from the top of the building to the tip of the shadow is 37 meters. So 37 meters. So the question is, how tall is the building? So to find out, we just do a squared equals c squared, taking a little shortcut, minus b squared. Okay, it's minus 28 squared. So the length of the shadow is 37 squared minus, or the height of the building, sorry, is 37 squared minus 28 squared. So on your calculator, what is 37 squared? 37 squared minus 28 squared is 1305, and we do the square root, 36.1. So A equals 36.1. And that looks pretty reasonable. 36.1. And that's the height of the building, right? 36.1 inch meters. Okay, so there we go. The assignment number is number 83, the Pythagorean theorem word problems. And remember to show your work. Thank you very much.